Hello, I invite you to the third part of the introduction to the line of influence. Today, we will make a beam with a vertical skate and a sliding support. This is the third basic beam that we will be using in the future. In previous videos, I made such beams. This beam is also not complicated. We will calculate it quickly and then we will return to it. So we have to determine the lines of influence of reaction VB and the lines of influence of moment MA. Here, of course, is also the horizontal reaction, which is 0. So again, we see at a glance that VB is a constant value of 1 because wherever the force goes on our beam, from the sum of projections on the y-axis, VB must take it, as there is no other vertical reaction. And the sum of moments can be determined analytically now. -1 plus VB equals 0, so VB equals 1. From the sum of moments at point A, we calculate reaction MA. So the equation looks like this. 1, I assume clockwise positive moments. 1 at distance x, of course, Massachusetts, plus 1 at distance x minus VB at distance L equals 0. From this, MA equals VB times L, which means 1 times L minus x. Minus 1 times x, so minus x. Therefore, MA equals L minus x. I check for coordinate 0, for coordinate L. And I can check here at the end for coordinate L plus C. For coordinate 0, it is L. For coordinate L, it is 0. And for coordinate L plus C, it is minus C. Now we draw these lines of influence. Here we have from minus L through 0 to C, and here we have a positive one throughout the length of the beam. And now the shear forces. First, the line of influence of the shear force in section K. Again, as I said before the section and after the section. So first before the section ranging from 0 to A. I calculate the shear force in section K looking from the left side. So if the force is before the section, I see it, which means from the left side it is -1. If I did it from the right side, no problem, it's the same. It always has to be that way. And now if the force is after the section, ranging from coordinate A to coordinate L plus C, I look here as well from the left side. There is no force anymore, no other vertical or shear forces. So the force in this section is equal to 0. So if the force is before the section, we have -1, and if it is after the section, we have 0. And now the line of influence of the bending moment in this section K. Well, so the force is before the section again. Now I'm looking at this moment from the right side, because why not? So here, when I look from the right side and the force is before the section, I don't see it from the right side here, which means it will only be VB times the distance from the support to the section, which is B. It's positive because the moment is counterclockwise. And in this section, a counterclockwise moment is a positive moment. I determined VB earlier, it is 1, which means I just have B left, which is the whole value B. So if the force is before the section, I have the influence line of the moment in this section, K, a constant positive value B. And now if the force is after the section, I look from the left side. It comes out the same if I calculate from the right side, just to make sure there are no doubts, but I calculated from the left side here. So if the force is after the section and I look from the left side, I only see moment MA. It's clockwise, which means positive, so it's simply MA. And MA, which I calculated earlier, is LX, so it will be LX, which is actually from this point, from this section here on the influence line of the moment in section K. And we already have the same as the influence line of moment MA, because it is simply MA. But I will check here for coordinate A, I have LA, and L is A plus B, which leaves me with B, which is what we got here before. And when I substitute L, I get 0, and when I substitute L plus C, which is the end of the interval, I am left with minus C, which is exactly what the influence line of moment MA is. And this is how the graph looks. Here it could actually have been a mirror reflection, positive moment at the bottom, negative at the top, but it doesn't matter much. And that's everything for this example. If there are any questions, I encourage you to comment on the video. I will definitely respond. Of course, visit us on Facebook, visit our website, and be sure to subscribe. Bowing out, bye.